first session, we talked about measurement and significant figures, and I want to reiterate a very important point, that all measurement has uncertainty attached to it. In fact, I'll go back further and say, on the skill of observing, all observations have uncertainty attached to them. Uncertainty has to be recognized in the observation. Uncertainty has to be recognized in the measurement. For instance, when we say something weighs 13 or 17.35 grams, that means we observed 1 and a 7 and a 3, and there was uncertainty attached to the digit to the far right. The digit to the far right. The number of significant figures in this number, however, is 4 significant figures. Now, significant figures is defined as all numbers that are certain plus 1 uncertain. All certain or observed directly plus 1 uncertain. Now, this could be an estimate, and this usually comes from the least count of the instrument. The least count is the smallest interval that the instrument you're doing the measurement with, the smallest interval it will give you. For instance, on a ruler or on a metric balance, 1, 7, and 3 is observed directly, and this suggests that the 17.35 grams is really plus or minus 0.01 grams. And this value here, many times they'll have other than a 1 here. They could have 2, which suggests over repeated measurements, they see that the balance varies more than plus or minus 100ths. It may vary plus or minus 200ths, say. But this is our uncertainty, this last digit. Now, you could say, well, I still don't get it. What is significant figures? Well, a significant figure is a figure that we value. You say, oh, what's that mean? If we have a measurement of 17.35 and we just say it's 17 grams, if we just stop there, 17 grams, what we're doing is losing information. We are not using all the significant information we have, the significant figures. Even if we say 17.3, we are losing information. 17.35 gives us the information that we have available. And remember, we can't go beyond the precision of the instrument. Let's say you want to impress the teacher and you say, I measured 17.3585 grams. And see, I did better than you guys. Well, did you? What you did is you went beyond the capabilities of the instrument, and these digits have absolutely no value. Just as in a calculator, when you have a whole string of values, most of those numbers are not significant. You have to bring them back to the level that you worked with in the instrument. Let's try this number again, because I think students have had trouble with this. 0.0035 meters. The number of significant figures here, what is it? It is 2. And the way you could get that is put it in scientific notation. When you have zeros to the left of the decimal point, the rule is no zeros to the left of this or less to the left of the number are significant. So if we count 1, 2, 3, we make that 3.5 times 10 to the minus 3. Now what happens? Look what happens if we kept the zeros there. It'd be 003.5 times 10 to the minus 3. 3.5 is the number, the coefficient. 0 makes it no more or less than 3.5. 0, 0 makes it no more or less. So those numbers are just part of the placeholder. They do not carry any value. Okay. However, if we use 0.00350 meters, now in terms of scientific notation, you count 1, 2, 3. So this becomes 3.50 times 10 to the minus 3. And you can see there you have, in this case, 3 significant figures. 3 significant figures. And over here you'll have only 2 significant figures. Now the last main topic on this little session I want to get is a strange one. Let's take this number, 3000, and we'll call it kilograms this time. Remember, chemistry works with quantities. That's a number and that's a unit. How many significant figures do we have here? If you say 4, you're wrong. If you say 3, you're wrong. Well, let me give you the answer. The answer is you don't know. Get this right here. You don't know. Now, why don't you know? Because the 3,000 can actually be plus or minus 100, if that's where you measured to, or it could be plus or minus 10, or it could be plus or minus 1. So you don't know whether, and you notice this could be 3,100 to 2,900. This could be 3,010 to 2,090. So you see why the answer is you don't know. But you do know at least one significant figure because all numbers are significant. So 3 is significant for sure. So if you present this number, 300, with a decimal point, now you have 4 significant figures. 4 significant figures. That's because everything is significant because you measured at the units point. This is 3,000 plus or minus 1. Okay, we will stop there, and you may want to go back and review significant figures 1,